Okay, 5.1, it's labeled rational expressions and functions. Remember, rational, a ratio is a fraction. We're going to be working with fractions here. We'll be multiplying, dividing, and simplifying. And actually, the very first thing we're doing isn't even simplifying. Find all the numbers for which the rational expression is not defined. When is an expression not defined? Not defined.
When x equals 0?
When the denominator equals 0.
Yeah.
If the bottom is 0, it's, you say not defined, right? So, we don't even worry about what's on the top. What this is asking us is find all the numbers that would make it an undefined expression. So we're just worried about this bottom. If that bottom equals 0, then it'll be undefined. We don't even mess with the top. Okay? So we said we have 3t plus 17 equals 0. So solve for t. Solve for the variable. We have 3t equals negative 17. Divide by 3. So there's only one number that will make this undefined. And it's not even a whole number. If t is negative 17 over 3, that would end up being undefined. It don't even matter what the top is. It's going to be some crazy number, but we don't even care. Okay? So what would make, what numbers would make, what numbers of x, what values of x would make this undefined, would make that 0. So add 45. So we have 5x equals 45.
You don't have to factor that over.
No. You could, but it's going to come out the same anyway. I'll show you in a second.
45
If you divide by 5, you get 9, right? Okay. What if we factored it and we've got 5 times x minus 9 equals 0. 5 equals 0 would not give you a solution, and this would give you the 9. So you could do it that way, yeah. Okay, this one we do have to, we have to factor to get the, what would make our denominator 0? Well, if we factor it, we got 7 times 11, 7 and 11 add up to 18, so that's the ones. To get negative 18, they're both negative, but you have to set each one of these equal to 0. So if you set that one equal to 0, you get what? 7. This one, and 11. So there's two numbers that would make the denominator 0. So that's how you figure out what would make it undefined. Set the denominator equal to 0. Okay? Everybody good with that? Okay. Find the domain. You're going to write both the set builder, that's a B. I made a bigger mess than I already had. Find the set builder and the interval notation for the answer. So this is the problem. Set builder is where you have a set of numbers where x of x such that x is, okay, this is set builder, this is interval notation. Okay. Find the domain. We're pretty much doing the same thing we did on the last one. X could be anything as long as it does not make the denominator 0. So we could put anything for x, except what?
be zero?
On that one, except -7. Okay, X can't be -7 because it'll make it not defined, or undefined, not defined, whatever. So X cannot be -7. Okay? So a set of numbers of X such that X is a real number and X is not equal to 7. The squiggles around it makes it set notation. Okay, or, Philip, how do we write this in interval notation? If it can't be -7, it can go all the way back to -infinity, right? Up to
-7.
up to -7, then we have a parentheses here because it can't be -7, right?
Yeah.
And what do we do here in between it?
Union,
Union. And we start
-7.
again at -7, but we don't include it. Remember, that's the parentheses, not included. -7 to where?
Infinity.
To infinity, to positive infinity. So this is our interval notation for X is not equal to -7. Okay? On the next one, what can R not be? It can't be 6. R is not equal to 6. R is a real number, and R cannot be 6. I'll give you a little bit of time to write. We'll let somebody else try it, using the one before. Give me some writing time. Okay. Vernon. Interval notation, what would we put here?
-infinity.
To what?
6.
And then what do we put here?
Union. 6. Infinity.
There you go. If it can't be something, it can't, you have to have the parentheses there, and that's the only thing that's skipped, is that one thing. Okay. This one, set mid equal to 0. Lawrence, do you have an idea what we need to do? Factor it, right. X, right? 3 minus equals 0. Set each one of these equal to 0. And 3 minus x equals 0. There's one of our answers. Yeah, we could add x. That's the quickest way. Okay, so x cannot be 0 or 3, right? X cannot be equal to 0 and x cannot be equal to 3. So there's two things it can't be. So we have 3 things here because we have to skip the 0 and we have to skip the 3. Right? So let's build this interval notation. -infinity, all the way up to the smallest one, which is 0. Union, from 0 all the way up to 3, but not including either one, right?
3. Well, union.
Union. 3 to infinity. Alrighty. We're going to start simplifying fractions. Because after we get an answer, you gotta make sure it's totally simplified. Just like a fraction, you always simplify a fraction, don't put 6/8, you always reduce that to 3/4, right? Okay. Oh, you know what? I didn't do this bottom one. Can the bottom equal 0 on that one? 6 cannot be made into a 0. So the set would be x such that x is a real number. It's not anything that it can't be. It's just a real number. Okay? Set notation all the way from
Infinity is 6.
no 6, it can be 6.
Oh.
X could be anything. There's nothing that we're going to exclude. All the way up to infinity, it could be anything. I don't know if you'll get any like that. I didn't see any in the homework, but I thought we should throw one in just in case, you know. If there's no X's on bottom, it could be any, the domain would be anything. Any real number. Okay, simplify. Alrighty. The 5 and 15. Okay, what do we divide them by? 5 is 1, divided by 5 is 3. Okay, the smallest exponent is what gets canceled away. Okay, think of this as 5y's and 4y's. You can cancel 4 on top and 4 on bottom. So get rid of all 4 of these y's, and 4 of those leaves 1. Okay, so you could actually look at this as like 3 times 5, 1, 2, 3, 4, 5 y's. This is 5 and 4 y's. Okay, so we get rid of 5 by doing divided by 5. We get rid of 4 y's. So all that leaves us with, on top is a 3 and a y. On the bottom we have 1, but you don't need that. So this actually just simplifies to just 3 and y. That's not on bottom. It looks like it's on bottom, but that's 3y over 1, which is 3y. Okay, the next one. What can we divide the numbers by? 7. It's 4, right? You know your multiplications if you don't know them. Okay, how many w's can we cancel?
2.
2. Get rid of 2 here and 2 here. What's left on top? Not 1. W to the first power, which is just w. 1 w. Right? Just 1.
Is that a 28 on the bottom?
Yes, it is.
You got to put the line.
This line?
Yeah.
Yes.
Did you put 4 on the bottom?
W on top, and you need something on bottom because we have some left. 28's not there, we have a 4.
Oh.
If that was all that was left, we wouldn't need a line. And that is reduced. Okay, the 16 and 24, what can we divide them by? 4, 8. 8's the biggest one, right? Let's go with the biggest. 8 leaves us 2. 8 leaves us 3. How many p's can we get rid of?
3.
3 and 3 of those. What do we have left on top? Just the 2. On bottom?
3p4.
3p to the 4th power. Okay? All right, what can we do to the top here? Can we cancel 9 and 9 here? Don't say yes. I'll smack you. No, you may not.